Hello and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem number 41. For problems 41 through 44, it says, evaluate f of -3, f of 0, and f of 2 for the piecewise defined function, then sketch the graph of the function. So for 41, it shows us this piecewise function, f of x equals x plus 2 if x is less than 0, and 1 minus x if x is greater than or equal to 0. Now, what a piecewise function means is what we can see here, right, is that there are two pieces of the function. So it means that, in a way, it's sort of saying that there are different conditions for the function. So if your x value here is greater than 0, then you're going to use the equation or the function 1 minus x. So if x equals 1, then we'll use 1 minus x. Now, here it says if x is less than 0, well then we're going to use this function here, x plus 2. So again, if x equals some negative number at all, then we'll use x plus 2. And so what that's going to do is it's probably going to give us two different looking lines. And so that's part of what the problem wants us to do is they want us to kind of figure out what happens with the function. How does the graph behave when we have these piecewise functions? So let's go ahead and start with f of -3. And now if we look carefully here, it says if x is less than 0, then we'll do x plus 2. So we can see that -3, right, is less than 0. That's going to be equal to -3 plus 2, which equals -1. Okay, so that part's done. Next we have f of 0. And this is where we have to be very attentive to our greater than less than signs and keeping track of where the equals sign is as well. And if we look here at this bottom part of the piecewise function, it says x greater than equal to 0, then we're going to use 1 minus x. So because of that, we're going to do 1 minus 0, and that will give us, not 0, sorry, that'll give us 1. Okay, and lastly, they want f of 2. So f of 2 is going to be equal to, well, right, greater than or equal to 0, we'll use 1 minus x. That's going to be 1 minus 2, which is going to give us -1. Okay, so let's go ahead and graph this now. So let's see, let's draw the coordinate plane as neatly as we reasonably can. And maybe we can have each big square equal to 1. So first we have -3, right? That's -3 there. And -3 gives us -1. When we have an input of 0, we get 1. Oh, sorry, I messed up the dot a little bit there. -3 gives us -1. I put it in the positive on accident. So anyways, then when we have an input of 0, that gives us 1. And when we have an input of 2, that gives us -2. So we go over 2, or -1, if we have an input of 2. So there we go. Now, we don't quite have all the information we need to draw these lines, at least for the first part of the piecewise defined function. The second part, we do have 2 points, and that's helpful. So with the second part of the piecewise defined function, we have 2 points, and because it's linear, we know that it's not going to change abruptly on us. So we can just connect those 2 points and draw our line. But this first part, we should find more values. We should find more values for it. That way we can get the appropriate line drawn in. So what happens if we plug in, let's see, we have -3 here. What happens if we plug in -2? That will give us -2 plus 2, which will be 0. And then if we plug in -1, that will get us -1, +1. Now, what we can see here is, with this graph, as we get closer to 0, we're going to approach the point 2, but because it's piecewise, right, and it's everything up to 0, not including 0, then at 2 we're going to have a hole right here in our graph. And the rest of this will go down like that. And so that is what our piecewise function looks like.